Question on cost minimization. The question is, a producer decides to minimize the cost of production. C is equal to 8L plus 2K, subject to Q is equal to 2L raised power 1 upon 3 times K raised power 2 upon 3. Where symbols have usual meanings, we have to find out the equilibrium combination of labor and capital in order to minimize the cost of production when the firm produces 64 units of output. Okay, so this is our cost function, that is C is equal to 8L plus 2K. Okay, we want to minimize this cost, and let me write it here. We want to minimize this cost subject to the production constant. What is the constant? So we have 2 L raised power 1 upon 3 times K raised power 2 upon 3, and we want to produce Q units of output, which is equal to 64. Okay, so it is, in fact, if I draw the graph here, simply we have units of labor on the horizontal axis, units of capital on the vertical axis. So with the given production constant, which is our ISO count here, we want to minimize the cost. So we can have this kind of ISO cost line and also this kind of ISO cost line. Now equilibrium occurs where the slope of the ISO count is tangent to the slope of the ISO cost line, and at equilibrium what happens? The marginal rate of technical substitution between labor and capital should be equal to input price ratio, that is price of labor upon price of capital. Now MRTS, as you know, it is simply marginal product of labor upon marginal product of capital, and input price ratio is price of labor is 8, price of capital is 2. Now MPL upon MPK, MPL means the change in the total output due to the change in the units of labor employed. Similarly, MPK means the change in the total production due to the change in the units of capital employed. It should be equal to 8 upon 2, which is equal to 4. Now dQ upon dL means the derivative of this function with respect to labor. Okay, so using power function rule, we are taking partials with respect to labor, so the exponent of L becomes coefficient. So we have 1 upon 3, then we have 2 L raised power minus 1 upon 3 by power function rule. K raised power 2 upon 3 will remain same. Similarly, dQ upon dK means partial derivative of this function with respect to K this time. So exponent of the K becomes coefficient, so we have 3 upon 2, rather 2 upon 3, 2 upon 3 into 2, L raised power 1 upon 3 will remain same, and exponent of this 2 upon 3, which is capital, will get subtracted. So 2 upon 3 minus 1 is minus 1 upon 3. It should be equal to this. Okay, so this denotes the slope of the ISO cost line, this denotes the slope of the ISO count line. Okay, so solving further, we get 1 upon 3 into 3 upon 2 times K upon L should be equal to 4. 3 gets cancelled, or K will be equal to 4 2s are 8L. Now we need to plug the value of K is equal to this into the production constant here, which gives us twice L raised power 1 upon 3 times the value of K is this 8L, 8L raised power 2 upon 3 should be equal to 64, which implies twice L raised power 1 upon 3. So in place of 8, can I write 2 cube? Then expanding this, we have 2 upon 3, then we have L raised power, also L raised power 2 upon 3 should be equal to 64. Solving further, so we will get twice L raised power 1 upon 3, 2, so this gets cancelled, 2 2s are 4, should, then we have L raised power 2 upon 3 should be equal to 64. Solving further, bases are same, we can add up the exponent, so we get 4 2s are 8L, because 1 upon 3 plus 2 upon 3 sums up to 1. So 8L is equal to 64, and dividing both sides by 8, so L will be equal to 8. Now plug, so we need 8 units of labor. To find out the units of capital, plug the value of L is equal to 8 in this equation. That gives us K will be equal to 8 into 8, which comes out to be 64. So we need 64 units of labor, and we can also find the corresponding minimum cost. So C will be equal to 8 into units of labor, which is 8, plus 2 times units of capital is 64. Solving, so C is equal to 64 plus, so C will be equal to now 192. That will be the corresponding minimum cost. So I hope I made myself clear in this video. Thank you.